Oh, okay. We're going to, I'm going to have one more video here. There's all kinds of other stuff you could share. What you could do is you could look up videos on YouTube of solving different trig equations, because there's just all kinds of possibilities. But these kind of give you a lot of the basic techniques, and then you can kind of use them in different ways. So this is using the sum difference identities. This isn't quite as common, but there are situations where it is handy. And this one is a very, very straightforward one. The idea here is you got a very complicated expression over there, right? But it looks like it could almost be one of the identities, one of the sum difference identities. So you have to go back and look and remember what these were. And sure enough, this here, I even wrote it in the same form. This here is the sum difference identity for sine, and it would be a difference. It would be a difference one. This is minus, minus, so this is a difference, sum difference identity. You just got to make sure everything holds. So this would be sine of 5x cosine of 2x minus cosine 5x sine of 2x. And that's perfect. I mean, that's exactly what we need. And so you can rewrite this as sine of 5x minus 2x is equal to negative square root of 3 over 2. And the nice thing about that is this reduces down to sine of 3x is equal to negative square root of 3 over 2. And that is a multiple angle identity, right? And so for sine, you'd have like negative square root of 3 over 2 down there. So that's a special angle, and this would be 5 pi over 3. This would be 4 pi over 3. But you have the multiple angle. This is a multiple angle, so I'd have 3x is equal to 4 pi over 3 plus k times 2 pi. And so I would have x is equal to 4 pi over 9 plus k times 2 pi over 3. So that would be one of my solutions. And then I would have 3x is equal to 5 pi over 3 plus k times 2 pi. And that would be x is equal to 5 pi over 9 plus k times 2 pi over 3. And that would be the next one. Okay? And so those are the solutions to that big, crazy equation. Okay? So, you have to be careful, though. So what I did is I wrote this out. And this gets really confusing for me, too. Okay? So using these identities here, can you maybe pause the video and investigate these and see which one you can actually solve? Because these things could be mixed up. I put it directly into the form it needed to be, but only one of these two are going to actually, you're going to be able to use the sum difference identity. So go ahead and see which one it is. Go ahead, pause. Okay, did you figure out which one it was? Okay, if you chose the second one, I think you're right, but it's terribly confusing here. Let me just make sure. So if I commute these around here, then I actually have exactly what I had up here. No. Is that right? So I'd get, I could commute those around, and then if I commute, or if I commute these around and then leave this the same way, yeah, so if I rewrote it like this, sine 2x sine 2x cosine 5x, and then this would be minus cosine 2x sine 5x. Then this could be reduced down to sine 2x minus 5x is equal to negative square root of 3 over 2. And that is doable because you could pull the sine out and commute those and you get a 3x here. That would be positive. And so this is doable, but this one is not even an identity here. You could try it. Go ahead and try to rearrange them, and this one won't even be, you can't even use the identity. Okay, so you have to be careful when you have to really pay attention when deciding what, if it's not just straightforward, deciding whether or not you can use the identity. Okay, and I don't want to just go on and on. So you look at that yourself, but you can see the point there. You have to be careful. Let's hit the autofocus. Okay, so now we have one more equation. Maybe I'll write this on a sheet of paper again because it's kind of messy there. It is cosine 3x cosine x minus sine 3x sine x, and all of this is equal to the cosine of x. Okay, so go ahead and look at these identities if you need to pause. Can you use either of these identities here to solve or to reduce this down? Okay, so as you look at it, you got both cosines, both sines, and so that is like the cosine sum difference identity, right? So I can collapse this down, and when I do that, that would make this a plus here. So I get, and you know what? This might not be what I was thinking it was going to do. So let me, did I write it down? I might not have written it down right. Actually, this I think should be a plus here, and then this thing will collapse down into cosine 3x minus x is equal to cosine x. And so that's kind of nice. You get cosine 2x is equal to cosine x. And when you look at the, if I can find it here, the double angle identity for cosine, can you see which one would be most helpful? You have a linear term of cosine here, so this would probably be the most helpful. And so I'm going to use that. And that would make this 2 cosine squared x minus 1 is equal to cosine x. And then I can bring that to the other side. And then I have an equation of the quadratic type. So I have a sum difference, double angle, an equation of the quadratic type. And this one, I think you can factor it. I think it is 2 cosine x. Can you factor this? Minus 1 or plus 1. And then cosine x minus 1 is equal to 0. And I think that'll work because I get negative 2x plus this would give me that. Yep, so that works. And so now this one just becomes cosine x equal to negative 1/2. And then cosine x is equal to 1. And we can solve these. Negative 1/2 is over here. So I have pi over 3. Negative pi over, or I'm sorry, 2 pi over 3 and 4 pi over 3. Okay, and then this one has its one solution right there. So this would just be x is equal to 0 plus k times 2 pi, which is just, it's just k times 2 pi. Here, I'm going to write it underneath. K times 2 pi. And I guess I need to write these over here. Um, 4 pi over 3 plus k times 2 pi. So here are my solutions to this equation. So kind of a whole bunch of stuff together, right? But you can use what you've learned, hopefully, to solve these. So I've kind of tried to make this a little systematic, building up the skills and then showing you a good variety of these equations. And I've tried to do it without just doing every single equation that's in your homework assignment. You may have to try to apply these things in different ways and get it. A lot of these are going to be pretty easy, straightforward, but some of these could be a little challenging. So if you have questions on them, please let me know. And possibly we could even do a Zoom or something and interact about this if you need to do that. These are going to be due Sunday night, so you have some time to do these. So hopefully these videos are helpful, and let me know if you have any questions.